Alright, this video is going to be on how to find the equation of a derivative. So when we talk about the derivative, we're talking about the slope, the instantaneous rate of change at a point on the curve. So if we're finding the equation of a derivative, we're going to find the equation that you would be able to plug numbers into to find the individual slope at individual points. But this would be a general equation that would work for all of the points on that curve. So to find the equation for just the derivative, instead of a specific value for the slope at a specific point, we're still going to use that definition there of a derivative. So we're going to say the limit as h approaches 0 of f of x plus h minus f of x divided by h. And here we would just say we're not plugging any number in for x. We're going to leave x as it is. All right, so to find the equation of a derivative, don't plug a number in for x. Okay, so once you have found the equation of the derivative, then if you want to find the individual slope at those specific points, you could. So for example, let's say we want to find the derivative of f of x equals x to the third minus x. So I'm going to go ahead and take this equation, and I know that to plug it into this I need to know what f of x plus h is, and I need to know what f of x is. And f of x is already defined, so f of x plus h is the one we're going to have to do a little bit of math for. So f of x plus h would end up being x plus h to the third minus x plus h. That is what f of x plus h would end up being. Alright, so I'm going to say the limit as h approaches 0 of x plus h to the third minus x plus h. So there's our f of x plus h minus our f of x, which in this case happens to be x to the third minus x, all divided by h. And this just requires a lot of expanding. That's all that we have to do for this. And the tricky part of this one is that x plus h to the third. So you can do this maybe on a separate sheet of paper, on the back of the page, or off to the side. So x plus h times x plus h times x plus h is what I'm doing here. And I'm going to go ahead and multiply these out first. And I get x squared. And then I have an x times an h, and then an h times an x. So that gives me 2xh. And then I have h multiplied by h is h squared. And I'm going to go ahead and take that and multiply that times x plus h. That's going to make this quite a bit messier. So x squared multiplied by x is x to the third. X squared multiplied by h is x squared h. Then 2xh multiplied by x is 2x squared h. And 2xh multiplied by h is 2xh squared. And then we have x times h squared. And then we have h squared times h, which would be h to the third. Goodness gracious. Okay, so I'm going to go back and write down what I have now. The limit as h approaches 0, and I have x to the third plus x squared h plus 2x squared h plus 2xh squared plus xh squared Oh, I can combine those, so 3. Oh, and I have 3 of those as well. Silly. So plus 3x squared h and 3xh squared, and then plus h to the third. And then I have minus x minus h, and then I have minus x to the third plus x. And that whole thing is divided by h. Alright, so I can see my x to the thirds cancel, and I can see a negative x and a positive x cancel. And then I'm going to go ahead and write out what I have. I've got 3x squared h plus 3xh squared plus h to the third minus h, all divided by h. Oops, that's what I've got. And you have two methods you can think through for the rest of this. If you want to factor out a common factor on the top, then you could and see if it cancels on the bottom. Or you could just say all of these pieces have an h, and I've got 1 on the bottom. So I'm going to take the 1 on the bottom, and I'm going to ditch 1 in each of these pieces. So whichever way, you can factor out a GCF of h and then have it cancel. And actually, that's not a bad idea. I'm going to go ahead and write that. So I've got a GCF of h. That leaves me with 3x squared plus 3xh plus h to the second minus 1, h on the bottom. And so that's kind of going back to our limits where we had holes. We had that factor that canceled. All right. And for all of these, I'm still saying the limit as h approaches 0. The limit as h approaches 0. And so that means at this point, I can take that thing that I have now, and I can plug 0 in for h. And what you'll notice when you do that is that this part is going to 0 out, and this part is going to 0 out. And so you're going to find that the derivative, the equation of the derivative is 3x squared minus 1. So that derivative right there will allow you to find the instantaneous rate of change at any point on that curve. You can just plug in the x coordinate that you're talking about, and then you'll know the slope at that point. Okay, we're going to do one more example in this video. And this example is going to say, given that f of x equals the square root of x minus 1, find f prime of x. So I'm going to go ahead and write out my limit for finding the equation of the derivative, because if you recall, f prime of x is just the notation for what a derivative is. So we're going to look for the equation of the derivative because they did not specify to find the slope at a specific point. So my f of x is this. My f of x plus h would end up being the square root of x plus h minus 1. And so now I'm going to go ahead and plug everything in. So I have the square root of x plus h minus 1 minus f of x, which happens to be the square root of x minus 1, divided by h. And hopefully you're recognizing that this is a conjugate problem. So I'm going to go ahead and multiply by the conjugate. So on the top, I'm going to go ahead and FOIL those two things together. I'm going to multiply it out so that I can get my like terms all together. So when I multiply these two pieces times each other, I just get x plus h minus 1. And then this would be this product but the positive version of it. And then I have the same product but the negative version of it. So I'm not even going to write it down because those two things would have canceled each other out. And then I have these two multiplied together, and a plus times a minus means that I'm going to be subtracting, and then it's just going to be that x minus 1. And on the bottom, I'm going to go ahead and not do the multiplication. I'm going to leave it kind of in this like factored form. And that's because I'm expecting a factor to cancel. That's very common with these problems for something to cancel on the top and bottom. So I'll go ahead and simplify what I have. I just distributed that negative. And I can see on the top that I've got a negative 1 and a positive 1 that cancel, and an x and a negative x that cancel, and all that is left over in this problem is that h on the top. And so then I'll go ahead and write that denominator out for the billionth time. And I can see that my h's are canceling, and they're going to leave a 1 on the top of that fraction. And this whole time I've been kind of sloppy, but all the way through I've got the limit as h approaches 0, and the limit as h approaches 0, and the limit as h approaches 0. And so at this point I can go ahead and plug 0 in for h, and I'll find that I have 1 over the square root of x minus 1 plus the square root of x minus 1. And those two radicals are the same, and so I'm going to call this 1 over 2 times the square root of x minus 1. And that is the equation of the derivative.